So the topic is stack. We know stack is a compound data structure and it belongs to a linear data structure. So stack is a compound data structure stack is a linear data structure. Linear data structure means either memory for this data structure is allocated in contiguous memory locations, or it grows, the data structure grows or shrinks in linear fashion. Stack is a logical concept. And stack works on LIFO principle. Stack is a logical concept and stack works on LIFO principle. What is meant by LIFO? LIFO is the short form for last in, first out. So in this data structure, the item entered lastly into the stack will be deleted first. So that is last in, first out. We will explain it. Now, stack data structure has one end and insertion and deletion of items takes place at this end and is called top. So in stack data structure, it has one end called top, and at this top, insertion of new data and deletion of an item takes place. So that end where insertion and deletion takes place is called top. Inserting an item into stack is termed as push operation. Inserting an item into stack is termed as push operation. Deleting an item from a stack is termed as pop. So there are two operations defined on stack: insertion and deletion. The inserting operation on stack is termed as push operation, and deleting operation or deletion operation on stack is termed as pop. So both this push operation and pop operation takes place at one end. So the new item will be added to the top, as well as when a pop operation is performed, the topmost item, the lastly entered item will be deleted from the stack. Now, when the stack is full, suppose a stack has 10 locations and we have entered all the 10 items into the stack, and again we are trying to add new item. What happens? There is no space in the stack to accommodate the newly coming, the new item. So it generates a message called stack overflow. So when the user tries to insert an item into a full stack cannot accommodate that item. So such a situation is called stack overflow. Inserting an item into a full stack generates stack overflow. Stack overflow. And if you try to pop an item from an empty stack, if the stack is empty and we are trying to delete an item or pop an item, it will generate a message. For that situation is called stack underflow. Deleting an item from an empty stack generates stack underflow. So these are the concepts about stack data structure. Now, see the practical example. You might have seen some buffet systems in receptions. There the catering team washes the plates and puts as a stack one after another plates at the counter. So the people comes to the counter and then takes plates from the top. One person comes, takes the plate from the top and he goes. Another comes, takes plate from the top and goes. As the people comes, people takes the top from the top, and the size of the stack or the content of the stack get reduced. And as the plates goes down, number of plates goes down at the counter, what happens? The catering people again washes new plates and brings new plate and place at the top of the plate set already there. And again new persons comes and takes the plate and goes. So that is the concept. New item will be added at the top and items will be deleted or taken out from the top. So the lastly inserted item will be taken out first. That is the concept of stack. Now this stack can be implemented in static fashion, that is using static arrays, as well as in dynamic fashion. Here we are going to see how a stack can be implemented using an array. So we have created, suppose we have created an array. Since it is static in nature, the maximum capacity is predetermined. Suppose the capacity of the stack is 10, and we have named this array as stack for our convenience, stack, and it can occupy a maximum of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, a maximum of 10 items. So here the size of stack is size of stack is size of stack is 10. Now initially we will keep a pointer that is called the top, and its initial value will be -1. Initial value of top will be -1, which means there is no items in the stack, or the stack is empty. Now we are going to insert an item, add an item, or in the term of stack we are going to perform a push operation. So what will be the code for this? So in order to push an item into the stack, the condition is there should be space in the stack to occupy that item. Let this be an integer array. We have to handle integer numbers in this stack. Now, so the first condition is we are checking whether there is space in the stack or not. The name of our array is stack. So we can write the code like this, algorithm like this. If, so this is the algorithm for push operation. If top, that is top, this top, when it reaches here, that is the maximum, right? So we have to check whether the top is less than this or not, less than the last space or not. So we can compare this, make a condition like this: if top less than size -1, if top less than size -1. What is size here? Size is 10. What is size -1? Size -1 is 9. If, in this case, if top is less than 9, that is, if top is here, we can add items, which means there is space in the stack to occupy an item. So if the top is less than size -1, then what we have to do? Top equal to top plus 1. Top is to be incremented by 1. Top is incremented so that it should point the next location. So top equal to top plus 1. Now we are adding the value. Array name is stack. Stack of top equal to, let value be the item to be inserted, equal to val. Then else, if this is not the condition, top is not less than size -1, which means it has already occupied the maximum number of items that can be occupied by the stack. that can be accommodated by the stack. Then such condition is called, so we have to print stack overflow. And if. So this is a simple logic for push operation. Now consider the example. Suppose this is the stack, it is empty. Now this is the position, top is -1 initially. Now we want to add, let value be value, we are going to add a new item, value say 125 to the stack. This is the new item to be pushed into the stack. Now we are making, when push operation is initialized, it checks whether top is less than size -1. In this case size is 10. So here size is 9. Top is initially -1. So it is less than size -1. So we can perform this operation, top equal to top plus 1. Value of top is incremented by 1. Top is equal to top plus 1. So what happens? Top points this position. Top becomes 0. Now stack of top equal to value. Stack of top. Stack of top. Top is 0. Stack of top. What is value? 125. So this value will be inserted to this part, this position. Now again, another item comes. Let we have to insert 425. Let this be the new item. Again the comparison is done. What is top now? Top is 0. Whether it is less than size -1. Yes. Then top equal to top plus 1. Top is incremented. Top becomes 1. Top is going to this position. Top here. Then stack of top equal to value. So the new value is 425. That will be added to the stack. That continues. And suppose, let this be the top position, and we have an item here, 300 here. Now again we are performing push operation. Top. What is top now? Top is 8. Size -1 is 9. So top less than size -1? Yes. So we are going to add a new item. Let it be 25. Top equal to top plus 1. What becomes top becomes, this is top now. Stack of top equal to value, so value is 25. This will be ended here. Right? Now the stack is full. Or items, the stack has the capacity of maximum 10 items. Already the stack is full. Now again we are initiating a push operation. What happens? What is top now? Top is 9. If top less than size -1? No. Top is already 9. 9 is not less than 9. So what happens? This block will not be performed, else print stack overflow. So the message will come stack overflow, it cannot accommodate new item. So this is the algorithm for push operation. We can convert this into C++ code like this. And we are writing a function, say void push int val. Let this be the value to be pushed, that comes as parameter. And suppose stack is our array, top is initialized to -1 and it is a global variable, and size of the array is also a global variable, it is also initialized. So all these are global variables, a global array, global variable top, global variable size. Now when push is called, we have to check if top less than size minus 1. If this condition satisfies, we have to perform top equal to top plus 1, top equal to top plus 1, or top equal to top plus plus. Then stack of top equal to val. Else, if that condition is false, we have to give a message cout stack overflow. So this function can be used for performing push operation. Now we shall see what happens when the pop operation is performed. So these conditions are same. Now what will be the algorithm? So in order to pop an item from a stack, we have to check whether there is item in the stack or not. So if there is an item in the stack, the top will be greater than minus 1. So we can make a condition like this. If top greater than minus 1, if top greater than minus 1, then we can print stack of top. Now we have to decrement the top equal to top minus 1. Else print stack underflow, which means there is no item to delete. So this is the algorithm. So let us check. Now the top is 9. Top greater than minus 1. Yes. Then what is to be done? Print stack of top, which means this item will be popped, deleted. And top becomes top minus 1. Now this is the top. This item get deleted. Now again another pop operation is performed. What happens? Whether top is greater than minus 1? Yes. Then this process continues. Top becomes top minus 1 and go on. And let now top equal to 0. Again 0. Top greater than minus 1? Yes. Then that item is to be deleted. 125 will be deleted. Then top equal to top minus 1. Top becomes minus 1. Now top becomes minus 1. Now again pop is called. Top is now minus 1. Top is greater than minus 1. Now that condition false. So this part will be executed. Stack underflow. So this can be, we can write function for pop operation. C++ function for performing pop operation. Suppose again stack is a global array. We have top a global variable and we have size not required here. So the integer value is returned from the function pop no arguments. Now we have to check whether the top is greater than -1 or not. If top greater than -1, what is to be done? We have to return, we have to give back the first item in that is the top item in the stack. So we have to write, we can write statement like this: return, give back to the person or to the program who requested pop operation. Return stack of top minus minus. So this is a complicated statement. Return stack of top. Suppose here is the top. So 300. Let this be the top. Now the top is 2. Top is 2. Return stack of top minus minus. Stack of top minus minus means this is post decrement, which means this after executing this function, top content of top will be altered. So stack of top minus minus. What is top? Top is 2. So stack of top will be returned. That is top of 2, top of 300 will be returned. So this item will be deleted. And after returning that, top becomes minus minus. That is top points here, top becomes 1. Now else, if this is top is not greater than -1, see out stack underscore then return 0. So this can be the function for pop operation. You can write this in many different ways. So I am using this code. We can perform this pop operation using this code. Now, what are the applications of stack? See, actually, there are many applications. One of the applications is converting expressions into different forms. That is, this is an expression, a plus b, c minus d. This is an expression. The a, b, c, d are operands. This plus, star, minus, all these are operators. Since these operators are placed in between the operands, this is called infix expression. Infix expression. In computer science, an expression is not evaluated in this format. It is either converted into postfix expression or prefix expression, which means this expression can be written like this: a, b plus c, d minus star. So here a, b are operands plus is operator. This operator is placed after this operands. So this is called postfix expression. Then c, d minus, and again after performing this operation and this operation, they are multiplied if you are using bracket like this. So this is called postfix expression. So for converting expression into postfix and prefix expression, we make use of this stack. Another application is for reversing a string, suppose this is a character stack. Suppose we have a word like this, Alex. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alexander. Suppose we want to reverse this string. What we can do? We can push all items. Alex, like this. Perform push operations with all the characters. Then perform stack continuously. That is pop operation. That is REDNAXELA. You will get this reversed string. So for reversing a string, we can make use of this stack. So this is the concepts about the linear compound data structure stack.